Hello, and welcome to project number 4 in our Intro to C programming course. This time around, you can see I'm back in Notepad++, and what is our project this time around? Given a number from the user, we're going to check if it is even or odd using two different methods. First method we're going to be using is the modulo operator. If you recall, the modulo operator is similar to the integer division operator, except instead of returning the quotient of the division, it returns the remainder. And method number 2 is we're going to be using the bitwise AND operator. I have a long comment down here that will explain how that all works when we get to that. Broken it down into a few steps again. Get process user input. We're pretty familiar with that by now. Passing the value to the relevant function, which kind of splits off into two things here. Instead of making two separate programs, like the last time I did something like this, I think it was last project actually, I'm just going to have two different functions and we're going to ask the user which one they want to use. Method number 1 is we're going to use the remainder of the value divided by 2 to get the result. And method number 2 is we're going to check if the ones bit of the value is set to get the result, and I misspelled value. Okay, fix that. And lastly, after we do whichever one of these two methods we need, we're going to print a message to the user containing the result. So, pretty similar to other things we've done, so let's get started here. If my chair would stop trying to kill me. There we go. So, first thing we need, if we're going to have those two separate functions, we should go ahead and declare them. So let's have int is odd mod, and this function is going to take one argument. It's going to be called int val, and then we're going to have a similar declaration here, int is odd and it's going to take a similar argument. Cool. We will define these functions properly later. This is just declaring them so that later down in the file we can have them down there and everything won't be in the way. Int main. As you can see up top here, I've already included standard io.h. So let's get to work here. At this point, we should be pretty familiar with prompting the user for input and for processing that input from the user. I'm going to use the fgetS method again because I just personally prefer that one. So let's get started here. Printf, string, please enter a number to test the oddness of. Have a new line character there so everything doesn't get really ugly. Then let's declare our buffer here. So character array buffer. Let's have it be 64 bytes. Initialize everything to 0 to make sure nothing goes wrong. Let's see. I need fgetS. We're going to, the buffer is buffer. The number of bytes in it is 64. And the file stream is standard in. I need int value 0. Value equals a2i from buffer. And if you remember from last time, a2i is not in standard io.h. a2i is in include standard lib.h. Cool. Again, from last time, this should be pretty familiar, but I'll run through it again in case you didn't watch or skipped or just forgot. So what this does is we have an array of 64 bytes. They're all set to 0. fgetS will get a line of input from standard in, so just from the keyboard input to the terminal. it will load whatever it gets into buffer up to 63 bytes. That last byte, if it needs to use it, will be guaranteed to be the null bit or null byte at the end of the string. Then we have int value equals 0, and we're going to load into value whatever number we typed in to into the terminal. If we didn't type a number, A2I will give up and return 0. So, that should be pretty familiar to us by now, and we're going to do something similar here in a moment. So printf, helps if I type it correctly. Would you like to test using the mod operator % or the AND operator? That key, there we go, ampersand. So this is going to be a little different from the last time I did this, in that instead of getting a number, I'm going to expect one particular character in the output, or in the input. So instead of we don't have a reasonable default here. We're just asking for one of these two characters, and anything else, well, we don't know what the user wants. So let's do this in a more robust way. If the user doesn't do what we ask for, what we need to do is ask again and tell them they did something wrong. So we're going to keep this line here, but we're probably going to move it in a moment. And I also should have a question mark and a new line character there. So how do we do this? We want to ask the user once, and if we don't get something we expect, ask again. Probably the best way to do this is a do while loop. So let's get that structure going. Do while something. What is that something? We need a character. So, well, we already have buffer, so we can just reuse that, because now that we have value stored, we don't need whatever's in buffer anymore. So let's just use that. So we're going to do whatever we do in this loop while buffer sub 0, so the first character in buffer, is not equal to the % character, and buffer sub 0 is not equal to the AND symbol. And that should work. So just to clarify what's going on here, and I'll delete that extra trailing space. So here's what's happening here. We have two separate Boolean tests that we're joining together. So how do we determine if this is true? If the first character of the buffer is not the ampersand, then this bit evaluates to true. If the first character of the buffer is not the ampersand? I said that wrong. My apologies. Let me back up. If the first character of the buffer is not the % sign, this bit evaluates to true. If the first character of the buffer is not the ampersand, that's correct this time, this bit evaluates to true. If both of these other conditions are true, then this whole ordeal, joined together by this double ampersand symbol, will evaluate to true. If this whole thing evaluates to true, then the condition for looping is met, and we will jump back up to the top of the loop after we check it. I think this works. This probably isn't the way I would have written this if I wasn't just doing it all at once. Let me try to rewrite this in a way that makes more sense to myself. So if it is not the case that buffer sub 0 is the first symbol, or is the percent symbol, or buffer sub 0 is the ampersand. If I could find the right key. There we go. I can never remember the order those are laid out in. This makes a bit more sense for me to read. So while these are semantically the same, I find this easier to read because what it does is it checks. This check will be true if the first character is a percent. This check will be true if the first character is the ampersand, and this double pipe symbol here will make this whole bit true if either one of the conditions is true. And then this bang here just checks that it is not the case that this is true. What this means is there are fewer knots floating around in here. So I think what I'm going to do is I'm going to delete this bit, copy that line, paste that there, and I will write a comment to myself right below it, because the while needs to be on the same line as this, if I recall correctly. So do stop the loop if the first char of buffer is percent or ampersand. That explains it pretty well. Cool, and now you've seen the thought process behind defining conditions like this. Not only do you need to define it in such a way that that the computer understands it, but that you can understand it. Another way to go about that is to write out an entire truth table. So given the inputs, so is the first character of buffer the percent, is the first character of the buffer the and then you run through all of the logic yourself and write out all the results to make sure that you're actually getting the result that you want. I kind of did. I didn't do that. I kind of did it in my head while explaining it out loud as best as I could. So, let's get into what we're actually going to do in the loop. First thing we're going to do is we're going to do the user input prompt. So let's do that. Copy that, paste that line. That's where we wanted it. And we're going to delete that line. Cool, so now the prompt for input is part of the loop and not outside of it. We're going to get s buffer 64 from standard in. And we are going to, now we need to check if, so now we're coming up against, we're coming up against an issue where I need to check the same thing twice. So maybe we can change what this is. Or, you know what? No, it just makes, it's easier to read if we just check the same thing twice. I'm not worried about being efficient here. So let's say if buffer sub, or let's use the same condition. Let's use the same condition. That way we, that way everything is internally consistent. So once again, If it is not the case that the first character of buffer is either the percent or the ampersand, we're going to run the code in this if statement. Printf, please put the proper character for the method want. Let's see, and just for clarification, character I didn't recognize, %C. And we're going to output the character that was in error when user does something bad. Cool. This should handle our input checking. Just to double check, I'm going to compile this. So gcc star.c out project4.exe. No output, that means it worked. Going to run it real quick. Let's just enter 65535. Huh. Okay, that's interesting. Oh, you know what? I know exactly what I did wrong there. Regardless, I want to check if this works, so I'm going to put in a $. Cool. Let's put in a rows or an @ character. Cool. And lastly, I'm going to put a % in, and it works just fine. Cool. Okay, so what did I do wrong there? If you noticed, the % in this bit of output here was not printed. That's because I forgot something. Printf, whenever it sees a %, it expects a format specifier, like say %d or %c that we use down here. And the way you work around that is you just have a double %. And this tells printf, no, I'm not giving you a format string, I'm actually giving you the % to print out. And just to clarify, %c as a format specifier says the next argument I pass you will be a single character that I need you to output to the screen. But other than that, I know that that fix will work. Actually, I'll just double check anyway. Let's go do that. 4, and cool. Now we get the output we expect. Excellent. So now it's time to determine which of our two functions that we're going to use. We have these two functions here. So, if buffer sub 0 equals %, that's the modulo operator, so we're going to use the modulo operator. Let's call we're going to be calling, God, what did I name that function? I have the memory of a goldfish. I will just do this. And this isn't all we're going to do here, but it makes a good outline, and we will expand upon this later. Then, else if buffer sub 0 equals ampersand. I named this value, so I'll go ahead and replace this with value. Cool. Now, figuring out how we want to get our output done is probably the last thing we'll do with this. Right quick, I want to jump to the actually interesting part of this and write these two functions. So I'm going to just copy their declarations put them down here, and replace those semicolons for the forward declarations with the curly braces for their bodies. And so remember, up here we are just telling the compiler that these functions exist somewhere in the code and not to panic when we call them. And down here is where we actually tell the compiler, okay, this is what these functions actually do. So let's get to work here. How do we, so we're going to be using the modulo operator here. And modulo, the way we're going to test if the number we get is odd is we're going to try dividing it by 2 and see if there's a remainder. All even numbers are divisible by 2, and so the remainder will be 0. All odd numbers are not divisible by 2 evenly. The remainder will be 1. So let's do this. There are a couple of ways we could do this. One way is to just have this function be one line long. Return val mod 2. And so if value is even, this will return 0. If value is odd, this will return 1 instantly. We can be a little more verbose with that. We can say if val mod 2 equals 0, we return 0. If val mod 2 equals 1, return 1. That, and make that an else if. And this is more verbose, but it is semantically identical to this and does the calculation more times if it needs to. So I think I'm going to use the one-liner method for this because this is relatively easy to understand. At least I hope it is. If you're not understanding what this does, we go over the modulo operator in the lectures, and I encourage you to play around with the source code, rewatch the videos, do whatever it is that you need to do to form a model in your mind of what this operator does to the operands you give it. Now, this one is one I'm going to go into a lot more detail on, using the bitwise AND operator. So you can see I've written a long comment here. Consider what an int looks like in memory. Remember that memory doesn't hold the numbers themselves, it holds electrical signals representing ones and zeros. So everything in memory is just binary. So a int in memory is 4 bytes of 8 bits each, so that's 32 bits. For clarity in reading it, what I'm going to do is I'm going to have them be in 4-bit chunks, and I'm going to separate the bytes using a pipe character. Cool. So now we have our 4 bytes in memory. Any of these bits can be set, and but for smaller integers, usually we're just going to be looking at the first 2 bytes or maybe only the first byte. I have an example down here. Consider the binary numbers 11, 12, 13, and 14. This is what those numbers look like in binary. Notice how in the odd numbers, this rightmost bit is set. In the even numbers, so 12 and 14, the rightmost bit is not set. Quick crash course for binary. Binary is just another way to count. And in decimal, each digit in a number represents a power of 10. So in this number, 4,582, that 4 means multiply that 4 times 1,000, or 10 to the third. The 5 represents multiply that 5 by 100, or 10 squared, 10 to the second. 8 says multiply that 8 by 10, or 10 to the first, and that 2 says multiply that 2 times 1, or 10 to the 0th. Binary is the same way. Each binary digit, or that's what bit is short for, represents a power of 2. So 1011 says multiply this 1 by 8, that's 2 to the 3rd. Then multiply 0 times 4, that's 2 to the 2nd, so we're just going to ignore the 4's bit. Then multiply this 1 times 2, or 2 to the 1st, and then multiply this 1 by 1, 2 to the 0th. Remember, everything to the 0th power is 1. Well, every positive integer anyway. So, actually, no, that's true for all real numbers if I recall correctly. Anyway, sorry, math is weird. So, if we check the 1's bit, we can tell if the number is odd, because every other bit is a power of 2, and therefore it's even. So the other bits would be 2, 4, 8. Then these bits are 16, 32, 64, and 128. After that, there's 256, 512, and 2 to the 10th is 1024. That's the biggest one I tend to have memorized at any given time. You could easily pull the other ones just by multiplying them by 2, but overall, usually if you're dealing with more than 2 to the 10th, you're just going to have a computer do it for you anyway. So, now that we have this understood, what do we do in order to check that that bit is set? Well, we know what 1 looks like as a binary number. 1 in decimal is equal to just 0001 in binary. Using the bitwise AND operator, we can get a number. We can get a value where all of the bits that are set in both the first and second operator, or operand, are set in the result. So, for example, let's say I have 0110, 0111, and I'm going to bitwise AND this. There we go. With 0100, 0001. The output of this would be 0100, 0001. You see how only the bits that are set in both values are set in the result, including this 1's bit here. If we want to tell if the 1's bit is set, all we have to do is do the bitwise AND with 1. Easy. So let's use the same thing we did up here, except return val and 1. That's fairly simple. So if, and this also conveniently returns a Boolean value. If value is odd, then the 1's bit will be set, and this will return 1. If value is even, then the 1's bit is not set, this will return 0. They have 0 bits in common. And this can be used as a Boolean value in an if statement. So let's go back up and do that. How do we want to do this? Let's do it the easy way. Let's do it the easy way for one, and the complicated but fun way for the other one. They'll produce the same results, but they'll just be in different syntaxes, so that you can compare how they are different but do the same thing. So, let's see here. Let's get rid of this. Put this whole thing in an if statement here. So, if this is odd, printf %d odd character, pass it value. Else printf %d is even. So that's the really easy way to do this. Now I'm going to do the kind of weird way. I'm going to use the conditional operator because I find that fun. If you remember what the conditional operator does, first you have a condition and then a question mark. And then if true, colon, if false. And these can be lines of code, they can be values. This whole thing is an expression that holds some value when evaluated. And so what we can do is printf %d is %s. Have the exclamation mark and the new line character. And then this %d means we're going to be getting value, passing it an integer. This %s means we're going to be passing printf a string to print out. How are we going to get that string? Well, first argument is obviously value. Second argument is, what did I call that? Is, odd, and for value. Then a question mark. If value is odd, we want to give it the string odd. If value is even, we want to give it the string even. And that's just an example of how you can use that conditional or ternary operator. So now that we have this, let's save our work. I closed my terminal because I am not very bright. That's also not quite what I wanted. That. Oh, now IntelliJ is going to open. That's not good. Thankfully, it opened on my other monitor, so I can just close it and not worry about it. Cool. So let me zoom in here. ANSI C, bash. ANSI C star.c -o project4.exe. Cool. Project 4. Let's start with 7. I want to test using the mod operator. 7 is odd. The same thing. I'm going to test using the AND operator. 7 is odd. Let's do the same thing, except we're going to use an even number this time. 8. 8 is even. And then back up here. 8. 8 is even. Excellent. One last test of the input sanitization. So let's do 2315. And I'm going to put just the number 0. Cool. It didn't recognize that, so it does the thing we expect. Excellent. So, as always, this source code will be available on the website. I encourage you to play around with it, compare it to your own code, and see if you can figure out why we did things differently. My code is not necessarily better than yours, it's just different. And I hope you had fun with this.